Let's go through LeetCode number 1293, shortest path in a grid with obstacles eliminations. To give us a grid and multiple by n grid. So we'll have inter m equals grid dot length and n equals grid 0 dot length. And it asks us to find the minimal steps to walk from the upper left corner to the lower right corner. And we can eliminate at most the k obstacles. So for this question, we can use the BFS, right? And for the BFS, we can have another that two-dimensional array, which we'll call it obstacles. Obstacles. Okay. So we use the BFS to use the BFS by those kind of grid from the upper left to top to right bottom, layer by layer. And also we are trying to see for these obstacles, right? So when we know if we arrive a node, right, arrive a cell which have the optical, that means from this one will record how many obstacles we eliminate from the up left. So only when so if we do BFS by layer, we know the steps is going to increase. And in the later step, if the obstacles we used is smaller than the previous one, we can still enqueue, right? Because it steps and there are two kind of dimension. One is the steps, another is how many obstacles. So even in some of the cases, if we have a larger steps, but if we have smaller obstacles, we can still enqueue. So we are trying to compare whether there is smaller obstacles. So what we're going to do is that we are going to put a large value for these obstacles. So we'll have private static int, final static int if equals integer dot max value shifts to the right. So we'll have arrays fill obstacles if. Okay. So we are going to enqueue the top left cell, right? You say that the grid 0, 0 will always not be an obstacle. Otherwise, when we enqueue, right, we should try to set this one as 1, right? So what we're going to do is queue, and we're going to have a row, column, and steps. New array. So we're going to have queue offer new int. This will be row is row 0 column, and currently we use the step 0, right? Actually, do we need steps? We just need a row and a column, right? Row and columns. We just need a row columns because we are trying to do the BFS and BFS layer by layer. So we'll have int step equals 0. While this kind of queue is not empty, we'll have int size equals to q dot size, and that we are going to do have for int I equals 0, I smaller than size I plus plus, right? So we'll have here we have size plus steps plus plus. So we know. So here we'll have int current equals q dot pull, right? Here, what we're going to do is that if current 0 equals m minus 1, and current let's have a row because we are using these parameters, right? So we are going to int row equals current 0, and int column equals current 1, right? So if we already have row equals m minus 1 and column equals m minus 1. We just return steps. And then let me see. We're going to have three put the third parameter as obstacles we have met so far, right? So this will be row, this one will be row, column, and obstacles, obstacles. Okay. We already eliminated. Okay. So we'll see we have current obstacles equals current 2, right? Then we'll have 4 directions. Private final static int d row equals 1 0 minus 1 0, and d column, d column was 0 1 0 minus 1. Okay. And we'll have 4 directions for int. Here there is k, let's say we are going to L equals 0, L smaller than 4, L plus plus. So we are going to have int new row equals row plus the row L, and int new column equals column plus d column L, right? So let's try to see whether it is inbound. If new row smaller than 0, or new column, new row greater equal to m, or new column smaller than 0, or new column greater equal to n. We're going to continue, right? Because this is out of bound. So if we visited the new row and column, we're trying to see whether this kind of whether this cell it is optical or not, right? So let's say inter new obstacles equals obstacles plus what plus if this is 1, right, then we're plus 1. If it's 0, then that equals the obstacles. So that will have greater new row, new column. Okay. So we are going to do is that we need to compare with this one with our obstacles array, right? So we know this BFS is by layer. We know at a later steps, if we visit some cell again, that steps will always be bigger. But if the obstacle is getting smaller, right? So but we still need to include, right? So if new obstacles, if it is greater or equal to obstacles new row, new column, we are going to continue because it's not getting better, right? And also the steps is get larger. We continue. Otherwise, we are going to update this obstacle new column because equals this kind of new obstacles. So this obstacle array is used pretty much like a weighted array, right? And also this kind of weighted array, if we have obstacle elimination smaller, even the step is greater, we should also include, right? New obstacles, and we'll queue offer new int, new row, new column, new obstacles. In the end, we just return. It is possible we do not cannot reach the result. Then we return -1, right? And also here there is one thing that if the new obstacles is greater than k, right, we should also continue. So if this one is greater than k, or this one new obstacles greater equal to this one, we should also include. Should also continue because we use more than k times. Return step, okay. Array into line 8 ratio. We should do this for 8. OB ops pose, right? Arrays view. Okay, sorry. And complexity will be O m multiplied by n.